What's up, guys? This video is going to cover our current project, starting with this template that I posted on Classroom. We've got a circle, that's not new. We've got a function and some conditions. We've done plenty of those before. The only new part is I've used this set timer function to animate and move the ball. You give it a function and a time, and it calls that function every, in this case, every 100 milliseconds. Okay? So what we have here is a bouncy ball, just like the beginning of video games. We had Pong and Breakout and so on. But currently there's an issue. It bounces way too late. It goes halfway through the wall, and the middle of the ball is what collides. We need to make the edge collide instead. So how can we do that? Well, if you use these built-in attributes, X and Y, that's the center, and we need to offset that center to get to the edge. There's already a name for that, that's the radius. So let's say, if we're going to the left, let's say ball.radius, and see if it can hit the left edge correctly. So when it comes around to the left, hey, that's better. That's a lot better, but it wasn't perfect. And the issue here is we don't really control the order things are happening. Maybe it redraws the ball every frame. Maybe it's before the update or after. Maybe it redraws the ball every time something changes. I don't want to get into that. Instead, we can just adjust it a little bit. So you see what's happening here is it goes too far, and there's already a name for how much it goes. That's what we've set as the velocity. So if we just want to adjust it by that, we should be in good shape. And then we don't have to worry about what order things are happening behind the scenes. Beautiful. It hit the edge just right and turned around when it should. So let's do the same thing on the other directions. I don't really want to copy this multi-part expression, and I don't want to have to worry about minus, minus, plus, plus, whatever. So instead I'm going to take that distance and give it a name. So we'll say offset equals radius plus velocity, and then we'll just use that in all the parts. And then if we decide that it's wrong and we change the offset, we only have to change it once instead of finding all four. Okay? So if we're going to the right, that's plus, and if we're going this way, that's minus. And a lot of people have a hard time remembering the vertical orientation because it's actually 0 at the top instead of 0 at the bottom like you might do in a graph. But when you're looking at it, you don't really have to know. You just say, okay, comparing to 0, it must be minus, and comparing to the max, it must be plus, you know. And we see that this is working perfectly well. It bounces on the right, and the top, and the left, and maybe you can't see it in the video because of my webcam, but it's perfectly bouncing on the bottom too, and you'll see it in yours when you make the adjustment. That's step 1, debugging. Step 2, I asked you to just try something. What if the ball changes size, or speed, or color, or something else? And let's make a little example of that. If you put something right at the top, then it changes every frame. And that's really obvious. You can see it getting bigger. And if we let that keep going, it might become too big and it'll run out of space. But it lets us see that we can add something and change it, and we do see the results reflected in the output. Instead of that, because we don't want it to just fill up the whole screen like Violet Beauregard, instead, let's make it change more rarely, like every time it bounces. What if it changes? Instead of radius, let's change the color, just for fun. Let's say, hey, every time it hits the top, oh, by the way, I noticed that I forgot the semicolon. And it was totally fine when we had one statement in there, but now that we have two, we want to make sure they're separate. What if we just say, Every time it hits the top, it turns black. And then we can test that, and when it comes around to the top, oh no, that's on the left. Hey, it turned black. There was, if you go to the sandbox and just make a new project in this format, there's a template that uses something called randomizer. So let's try that. There's a thing called randomizer, and it has a method called next color, if I remember correctly. Let's try that. Every time it hits the left, it'll go random color. Okay, that wasn't very different, but it was something. And that's the problem with random, is that if it's truly random, it might be ugly, or it might be too similar to the last one and we don't see. But let's throw it in there. Good reminder that we forgot our semicolons. And now we can see that the ball changes color every time it comes around. Maybe we can make our own colors and have it choose between some nice, beautiful primaries instead of some of this sludge, but it was a good try. Now, the next step is I said, hey, what if this is like a pool table? What if this is like a billiard ball bouncing around? Because I've seen some of you guys playing those on Cool Math. Now, the collision between two balls would be a little bit complicated if they're both moving and they both have to bounce off in different directions. You'd need some real geometry and maybe even physics. But at first, if you just have one and it goes in the corner, that's not bad at all. We're going to make a pocket, which is a circle we know how to do. It doesn't move. It doesn't even need a color because the default is black. And then we can check if our guy goes in. So let's take it. I'm going to remove the color thing, but it was a good try, and you can experiment with your own ideas. And instead up here, I'm going to go var, and let's delete this comment because it's not true anymore. Pocket is new, circle, and let's say 50 because it should be bigger than the ball, right? Because otherwise the ball can't go in. And then let's go pocket.set position. It's going to start in the corner, and the easiest corner is the top left because that's where we just give it numbers from 0. We don't have to go out minus anything. So let's just say 10, 10, and then let's go add pocket. Let's see, 3 lines, nice thing to test. Looks okay. I'm going to make it stick out just a little more. Yeah, that looks fine, and we can always adjust. And now, if the ball hits it, nothing happens because we haven't said anything about collision or actions or conditions. So what are we going to do? We need to say if the ball goes in the pocket, it disappears. Maybe later we'll have it reappear in the middle or have a new ball reappear, something like that. And your first guess might be to say, here it comes by the way, like that should count. In a real pool table, that would fall in even though it didn't perfectly line up. And so if your first guess was to say like, oh, if ball dot x equals pocket dot x or something like that, and just look for their coordinates to be exactly the same, well, that would be no good because it's super unlikely that they would line up pixel perfect with no, like the Venn diagram is perfectly lined up. So we're not going to do that. Instead, we're going to say, are they a certain distance from each other? And so here's the thing. If we check x and y, I'm trying to draw a little square here, we would make a square, right? And this is a thing in games, you have like a hitbox. And so if you check the horizontal and check the vertical, you're making a square. And we don't want a square hitbox for our circular thing because then it would either stick out too far or it would leave the corners uncovered. So instead we're going to use a round hitbox, obviously, for the round thing. How do we do a round hitbox? It's just a point and a distance. That's what a circle is. It's something, and then are you within my radius? So how do we do the distance between two things? A lot of you guys have seen this in math class. it's called the distance formula, and it's really exactly the same as the Pythagorean theorem. If you have a little bit over and a little bit up, that's two sides of a triangle. And if you want to find the real distance straight there, that's the other side of a triangle. So let's do it. I'm going to make a function, and I know it's ugly to say like x1, x2, y1, y2. I don't like it, but if we write it once, then we can just wrap it up in a function, call the function, and let it do its work. Okay? So let's say, okay, function distance, and I'm going to say, hey function, I'm going to give you some coordinates, x, y, and you're going to give me the distance. Okay, so x1, y1, x2, y2. Later, we might learn how to package those and to say, hey, here's a point in one unit instead of like x and y separately. And in that case, we won't have to label them with ugly numbers. But for now, this will do the job. Actually, x2, y2. That's the issue with these numbers, is it's easy to mess them up, right? And then we're going to go, okay, so the horizontal, the vertical, and then the diagonal. So we go x2 minus x1. That's our, sometimes you say rise over run. That's the run. That's the horizontal. And then we take that squared. The way to do square in most programming language is double star, because multiplication is single star, and exponents are like a super version of multiplication, right? And then y2 minus y1 squared, and then the square root of the whole thing. You got this big old line to show that we're square rooting the whole thing. There is a function for that. I think it's, in most languages, it's like sqrt, just like it is on the calculator. But there's also a way to do it with the same thing we've been using, the double star, because as an exponent, you can go 1/2. So 1/2 power is the same as square root, and in my opinion, that's not too bad. I know it's ugly because the whole thing is ugly, but we never have to look at it once we write this function. And when you make a function and it does a little job, the people who call it get that result of that job if you say return. Okay? So then we can say if distance of ball.x, ball.y, pocket.x, pocket.y is less than, let's just pick a number. We want it to be more than 1 radius, but less than 2. Because if it's both of their radii put together, then they would instantly fall in when the edges touch. We don't want that. If it's 1 radius, then they have to be perfectly lined up. But we want it to be like if the ball is hanging over the pocket a little bit, it would fall in, So I'm just gonna say like 75. That's just a guess. If it's no good, it's no good. And then I think we need some parentheses. And then you know how there's this add function, add. Well, I just took a guess. I said, I bet there's a remove. And it turned out, yes, there is. Whenever people make a setup like this, whatever it's called, a package or a library or an engine, they try to make the names sensible. So if there's a circle, they have a property called radius. I didn't have to make that because the circle already had something called radius. And if there's an add, people will assume that there's a remove, and guess what? There is. So if I run this, we're going to see if the thing goes in the pocket. Right here, it's going to be kind of close. No result because it wasn't within 75. It was within probably like 130 or something. But if we wait a second, it'll come back around and then go pretty darn close in a way that we did see earlier that I said should have counted, right? So let's see if it comes back around. and this should go in. Hey, it does. Even though it wasn't perfect, right? Like in real life, if a pool ball hits the corner near the edge and then it goes close and then the part of it's hanging over and then it slowly goes in, that is what we want. And that is pretty close to what we have. If we decide that we see an example, should have gone in but didn't, we can increase this number a little bit. If we see that one got sucked in a little too eagerly, we can decrease this radius a little bit. You might call it like the hitbox, even though it's a circle, or you might call it like an AOE, area effect. And we only needed one little baby function. I know it's ugly. I know if you look at this, you see all the math stuff, and we don't want to look at it. That's why we give it a function, and then down here you can just say the word, the English word, instead of all the dirty algebra that we don't like, okay? So that's the deal. It only took 2 lines to make it. It only took 2 lines to call it. That's not too bad. If you want to do something for the next step, think about when the ball goes in, we create another one, or really just have the same one teleport to the middle. Go from there. Thanks.